Hello good day viewers. In this tutorial we are going to learn how to find the angle between a complex number and the standard position. And this standard position, is just x-axis from the origin, that's 0 degrees or 0 radian. So we want to find the angle in between. We call it argument. We have some problems here 1 to 6, but before we start, let me explain this in detail. This is what I mean. Suppose we have a complex number z equal to a plus bi. Let us graph this. Suppose this complex number is situated in the first quadrant, somewhere here. A is the real part and b is the imaginary part, right? So we have this to be a plus bi. So the angle from the origin to this complex number between the standard position, this is the standard position. So this is the acute angle we are looking for. And we are going to learn how to find these angles. So we can simply form a right angle triangle here because it will guide us. And the distance here will be b and the distance here will be a. Remember that x-axis is the real part and y-axis is the imaginary part. So the distance bi is situated somewhere here and distance a along x-axis will be situated here. So what is the relationship between this angle and these two sides, opposite and the adjacent? Is tangent, right? So tangent of that angle, which is theta, will be equal to opposite divided by adjacent. The opposite is b and the adjacent is a. Therefore, theta can be obtained by taking tan inverse of both sides. Tan inverse of b divided by a. So if you apply this formula, it will guide you in getting this acute angle. And again, if this is known, suppose we have a value here for the distance. If you can find the distance, you can use one of the relationships sine and cosine to find the angle. Sine of an angle is opposite divided by hypotenuse. So sine of this angle is equal to opposite, which is b, divided by hypotenuse, which is r, which implies that theta is equal to sine inverse of b divided by r. And sometimes this complex number can be found within other quadrants. For instance, if it is situated here, this is going to be what? Negative a plus bi. Why? Because x-axis here is negative. So which angle are we looking for? We are looking for the angle from the origin, and it has to start from the standard position from here down here. But observe that finding this angle here is very simple compared to finding the bigger one. So we can use this one as reference. Whatever we obtain, we have to take it away from 180 or pi to get the actual angle, because from here down here is 180. So you have obtained this one. It means if you take it away from 180, it is going to give you this one back. So let us apply this idea in solving the rest of these questions. We have the first one here. So let me construct it roughly. You have to go to the real part 1, you go to the imaginary part 1. So the point of intersection between them will be what? That complex number. So this is our 1 plus I. But the angle we are looking for is this one. This angle right here. And you can see we have our right angle triangle right here. This is 1. This is also 1. So by applying that formula that says theta is equal to tan inverse of what? The opposite divided by the adjacent. 1 divided by 1 is 1, and tan inverse of 1 is either pi over 4 or 45 degrees. So therefore theta is equal to pi divided by 4 or 45 degrees. So you don't even have to apply formula here, because if you observe the distance from the imaginary part down to the terminal point, this is the terminal point. You see we have distance here is 1. And also from the real part down to the terminal point is 1. So the ratio is 1 to 1, halfway. And you know that the angle here is 90 degrees. If you divide it by 2, you have 45 degrees. All right, we have another problem here that we are looking for the argument of this complex number 2 plus 2 root 3i. We don't have to use any reference angle because this is in the first quadrant. Both real and imaginary parts are positive. So we can apply our formula direct. We have our angle to be equal to tan inverse of what? B divided by A. Let me even write it. B divided by A. This is equal to tan inverse of what? What is B? Is 2 root 3 divided by 2. And 2 root 3 divided by 2 is just root 3. So we are looking for just the tan inverse of what? Root 3. And tan inverse of root 3 is pi by 3. Therefore, this angle that we are looking for is equal to pi by 3, or which angle? 60 degrees. And we're done. Therefore, you can write it here that the argument of this complex number is either pi by 3 or in degrees 60 degrees. Question number 3. Observe that the real part is positive, but the imaginary part is what? Negative. So which quadrant is this one? Remember, if you have your quadrant like this, real part is only positive in the first and the fourth quadrant. But since the imaginary part is negative, it should be here, right? Suppose we have our complex number situated right here. So let me connect it from the origin. So this is the angle we are looking for down here. But we can use this reference angle because it is very simple to obtain this angle right here. And you know it is exactly the same thing with that angle from the first quadrant. This angle and this angle, they are exactly the same. So we are going to assume that we are in the first quadrant where everything is positive. So let me use the reference angle, reference theta. It will be equal to tan inverse of root 3 this time around divided by 1. And you know that root 3 divided by 1 is just root 3. And we have already seen that tan inverse of root 3 is what? Pi by 3 or 60 degrees. So this is equal to pi by 3 or 60 degrees. This is our reference theta. So if this angle right here is 60 degrees, what will be the angle from the back? Remember, the total will be what? 360 around a cycle. So if you take away this, because it is 60 less than 360, therefore this angle at the back will be what? 300. But how can we do that? We can either say that theta is equal to 2 pi minus pi by 3, or 360 degrees minus 60. So theta could either be equal to, we have 3 times 2 pi is 6 pi, minus 1 pi is 5 pi, so we have 5 pi by 3, or 300 degrees. Let us move to the next question. So here we are only looking for the angle between this complex number I. And this complex number I can be written as z equal to 0 plus I, because the real part is missing. So I want to let you know that whenever you have a complex number equal to only the imaginary part, if that imaginary part is positive, it should be 90 degrees. And if it is negative, it should be 270 degrees. Let me show you. Suppose we have the graph like this. You know, this is just an imaginary part. The real part is missing. And the coefficient of I is 1. So we have 1 unit along y-axis from the origin. You know, this is our imaginary axis. So from the standard position, which is this one, down to this axis is 90 degrees. You should know that. And if we have negative I, it will turn out to be from this direction again, here. So if you calculate from the standard position down to this axis, you have 270. And therefore, this is just equal to pi by 2, or 90 degrees. So here we want to find the angle between this complex number -1. You know, this can be written as z equal to -1 plus 0i. The imaginary part is missing. So let's construct this. We have our axis like this. You should know that if the imaginary part is 0, it is situated here. And the real part is -1. We are coming down here. -1. So from the standard position, if you count, you have what? 180 degrees or pi. Therefore, if you have only the real part, if that real part is positive, it should be 0 degrees or 0 radian. But if it is negative, it is going to be 180 degrees. So this is equal to pi or 180 degrees. Next question, and the last one. We want to find the angle between this complex number, -2√3 plus 2i. You should observe that the real part is negative and the imaginary part is positive. This is in the second quadrant, somewhere here. Let's assume it is here. So we are looking for this angle down here. So what if we should find this angle, which is reference? If we find it, we are going to assume it is in the first quadrant because it will have the same value with an angle here, this angle. So we are going to assume it is here. So let's find it. Reference angle equal to tan inverse of what? B divided by A. And this is equal to tan inverse of what is B? 2 divided by A. We are going to take the positive number, assuming we are in the first quadrant. We have 2√3. 2 divided by 2√3. This will cancel this. We have only 1 divided by √3. And if you multiply the top and the bottom by √3, you have √3 divided by 3. So it is the same thing as taking the tan inverse of √3 divided by 3. So the reference angle we are looking for is either equal to pi by 6 or 30 degrees. But remember that this is not the angle we are looking for. It is just the angle here, which is very close to 180. So because it is what? 30 degrees less than 180, we are going to subtract it from 180 just to get the angle at the back. So the angle theta will be equal to pi minus pi by 6 or 180 degrees minus 30 degrees. This is equal to 5 pi by 6 or 150 degrees. And this is the angle between the standard position and this complex number. It is either 5 pi by 6 or 150 degrees. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.